Welcome back, everyone, to the deep dive. Today, we are really getting into something fundamental if you work with databases. PostgreSQL indexing. You hear it all the time, right?
Right.
That it's one of the best ways to speed things up. So our mission today is to really understand how they work, what different kinds there are, and crucially, how to actually use them well. Think of it as a shortcut to getting a handle on this super important database tuning tool. We've pulled this all together from some top expert sources on Postgres.
And it really is fundamental because at its heart, the problem indexes solve is, well, it's slow data access. It can be agonizingly slow sometimes. When your database has to just scan an entire table row by row, especially as that table gets bigger and bigger, performance just tanks.
Yeah.
So yeah, understanding indexes is absolutely key. You can get huge performance wins, often without even changing your actual query logic.
Okay, right. Let's unpack that then. So super basically, what is an index doing? What's its magic trick for speed? I always think of it like, a massive textbook. If you need one specific fact, you could read every single page.
Right. Tedious.
Exactly. Or if it's got a good index at the back, you just look up the keyword, flip to the page, boom, done. Is that kind of what an index does for PostgreSQL?
Yeah.
Stops the endless page flipping. Sounds like a lifesaver after debugging slow queries all night.
That's a perfect analogy, actually. It holds up really well. Indexes mean the database doesn't have to do that full table scan. And those scans, as your data grows, they become a massive, massive bottleneck. So instead of grinding through every single row, the database uses the index, finds the location, and just jumps straight to the data it needs. It's direct access versus that exhaustive search. Saves tons of time, tons of resources.
Okay, that makes sense. So if we're using that book analogy,
Yeah.
what's the standard index, the one you find in most books? You mentioned B-tree. Sounds like the go-to. Is it pretty much always the answer, or are there times you need something else from the toolbox?
Yeah, the B tree, that's definitely the default in PostgreSQL, and honestly, for good reason. It's incredibly versatile. It works really well for both quality checks, where it equals 123, and also for range conditions, things like where price 50, or finding dates in a specific window. The vast, vast majority of queries people write, they're going to benefit from a B tree index. It's your reliable workhorse.
Got it. The workhorse, so it covers a lot of ground. But it sounds like maybe not everything. You hinted there are specific problems that need a different kind of tool. What else is in that PostgreSQL indexing toolbox?
Absolutely. Postgres gives you more than just B trees. It's got a whole suite really optimized for specific tasks where a B tree might not be the most efficient.
Yeah.
So for example, you've got hash indexes. Now this can be faster for just straight equality checks where column equals value, that specific thing. But, and this is a big but, they have serious limitations. You can't use them for sorting. You can't use them for any kind of range query. Less than, greater than, forget it. So honestly, they're pretty niche. Most advice is stick with B trees unless you have a really specific, high-volume, equality-only workload, and you really know what you're doing with the trade-offs.
Okay, so hash is very limited then. Good to know. What else?
Right. Then there are GIN indexes. That's GIN, generalized inverted indexes. Think of GIN as being great for complex container-like data types, things like arrays or JSON-B documents or even full text search. They're specifically built to efficiently handle operators that look inside these structures, like checking if an array contains a value using sim, or if a JSON-B object has a certain key using sim.
Ah, okay. So for searching within complex data, like digging inside a JSON blob.
Exactly. And then slightly different, you have GIST indexes.
Yeah.
Generalized search tree. GIST is more for complex spatial data or proximity searches. Think geometric shapes, finding things near other things on a map, that sort of stuff. Or even complex text proximity. They're super flexible for these advanced use cases. But it's worth knowing, sometimes for certain searches, they might actually be a bit slower than GM.
Slower. Why is that?
Well, because GIST is so generalized, right? That flexibility can sometimes mean a bit more overhead compared to GIN, which is more specialized for those array JSON text scenarios.
Interesting trade-off there. Flexibility versus specialized speed. Okay, any others?
Yeah, one more main type to mention, RIN indexes. Block range indexes. These are quite different. They're really designed for massive tables where the data has some kind of natural physical ordering on disk. Think timestamp columns that increase over time, or maybe auto-incrementing IDs. The big advantage of BRIN, they are tiny, really space efficient compared to B trees or GINGIST, but the trade-off is precision. They store summaries for ranges of table blocks, not exact row locations. So they tell the database, your data is likely in this large chunk of the table, not, it's right here. Less precise, but much smaller.
Wow, okay, so it's definitely not one size fits all. You've got the generalist B tree, then these specialists like hash, gin, gist, and brin for very different kinds of problems. That's already super helpful. But I've also heard about techniques that go beyond just picking the type, like ways to fine-tune things even more.
That's right. Once you've picked a type, there are more advanced ways to tailor the index. Really powerful stuff. One big one is partial indexes. Just like the name sounds, you only index a part of the table. So let's say you have a status column, maybe active, inactive, pending, and you mostly query for the active ones. You can create an index where status is active. It only includes the active rows. That makes the index much smaller, faster to update, and way more efficient for those common queries.
Ah, okay, so you filter the index itself. Smart. What else?
Then you have multi-column indexes. Pretty straightforward idea. You include more than one column in a single index, like indexing last name, first name. The key thing here is that they're most effective when your where clause matches the order of the columns in the index. So that last name, first name index is great for where last name Smith and first name Jane. It's also pretty good for just where last name Smith. But if you only search by first name, that index isn't nearly as helpful because first name isn't the leading column.
Right, the order matters. Makes sense.
And then there's a really cool technique called covering indexes. Usually involves the include clause. The idea here is you create an index on the columns you search by, but you also include other columns that your query needs just to return the result. So say you search by userid, but you also need to select the email address. You could index userid and include email, the magic.
Okay.
If the query only needs userid and email, PostgreSQL can get everything it needs directly from the index itself. It doesn't even have to go and look at the main table data.
Whoa. So it skips a whole step.
Exactly. It completely avoids that table access, which can be a huge performance boost, especially for frequently run queries. We call that an index-only scan.
Okay, partial, multi-column, covering. Lots of powerful options there. But this brings up a question. It sounds great, adding all these indexes. Is there a downside? Can you, go overboard, have too many indexes?
Oh, absolutely. That's a critical point. It's definitely a case where more is not always better. You can easily shoot yourself in the foot with over-indexing. So the when to index rule of thumb. Generally, you want indexes on columns you frequently use in where clauses.
Right, for filtering.
Exactly.
Yeah.
And columns used in join conditions because the database needs to match rows between tables quickly. And also columns used in order Y clauses because sorting large amounts of data without an index can be really slow.
Okay, where, join, order by. Got it. So when should you not index or be careful?
Good question. Be really cautious about indexing low cardinality columns.
Low cardinality, meaning columns with very few distinct values.
Precisely. Like a Boolean is active column where almost everything is true. Or maybe a gender column with just a few options. An index on such a column often isn't very selective. The database might look at the index statistics and just decide, it's probably faster to just scan the table anyway than to bother with this index that points almost everywhere.
Plus, you still pay the cost of maintaining that index. So unless you have a very specific reason and have tested it, avoid indexing those low cardinality columns.
Right, and that leads back to the too many problem.
Exactly. The danger of over-indexing. Remember, indexes are fantastic for speeding up reads, select queries, but they add overhead to writes. Every time you insert, update, or delete a row, every single relevant index on that table also needs to be updated.
Yeah.
If you have, say, 10 indexes on a table, that's potentially 10 extra write operations happening behind the scenes for every change you make to the data. That can seriously slow down your data modification operations.
Ouch. Okay, so it's a balancing act. Read speed versus write speed. It absolutely is, which leads to probably the most crucial best practice. Verify your indexes are being used. Don't just create an index and assume it's helping. Use explain analyze before your query.
Explain analyze.
Right. That command shows you the query plan PostgreSQL chose. It will tell you if it used an index, which index it used, and give you insights into why. It's your absolute best friend for understanding and tuning query performance. Essential tool.
Okay, check your work with explain analyze. Makes sense. Anything else for best practices?
It's just that it's not a one-time thing. You need to regularly review and adjust your indexes. Your data grows. Your application changes. The queries people run evolve over time. An index that was perfect 6 months ago might be useless now, or maybe a new query pattern has emerged that desperately needs a new index. So yeah, review them periodically. Keep them relevant.
Fantastic. So, boiling it all down, what we've really learned here is that smart indexing is, well, it's one of those powerful levers you can pull in PostgreSQL tuning. And the beauty is, like you said at the start, it often boosts performance dramatically without forcing you to rewrite your actual application logic or your queries. Just understanding these different types and techniques, B-tree, GIN, GST, partial covering, it gives you so much control. It's less about guesswork and more about informed choices.
Absolutely. It's about understanding the underlying mechanics. And maybe, as a final thought, consider how this applies more broadly. This deep dive into database indexes shows how understanding a fundamental structure, something often hidden, can unlock huge efficiency gains in complex system. So I'd challenge you, the listener, where else in your work, or maybe even other parts of your life, could a similar deep dive into the underlying structures, the indexes of that system, reveal hidden bottlenecks or unlock surprising performance improvements? What fundamentals are you maybe taking for granted that could be optimized if you just understood them a bit better?
And for everyone listening, remember, this is just the start. Keep exploring,